In this video, we are going to be looking at how light behaves when it goes from one medium to another. Here is the simulation as it appears when you first open it up. I'm going to click on Intro. What you see is you have a light source. You can turn it on and you get two waves out, or two light rays. This one follows the law of reflection, and this one follows Snell's law to refract. Notice right now, if I pull up the protractor, first off, all angles are measured with respect to the normal to the surface. So right now the incident angle is about 45 degrees, but the refracted angle is closer to 30. I also see right now I'm going from air to water. So when I go from a lower index to a higher index, the light ray bends towards the normal, or it refracts towards the normal. The refracted angle is less than the incident angle. If I flip it around and instead of going from air to water, I go from water to air, I see my incident angle is still at about 45 degrees, but now my refracted angle is much larger. It's about 70 at the moment. So when you go from high index to low index, you refract away from the normal, meaning that the incident angle is less than the refracted angle. Putting index 1 back to air and index 2 back to water puts us where we started again. If I change the material and go to glass, we see that the angle changes. The smaller the difference in index of refraction between the two materials, the smaller the amount of refraction. So when I put it at air, it goes straight through as if there's no boundary whatsoever. Water, as we saw, went from 45 to about 30. If I go to glass, it increases to just a little bit less than 30, or decreases to a little bit less than 30. So, on the other hand, if I put it back to water as my first medium, oh, better yet, let's go to glass as the first medium. We see from glass to air at 45 degrees, there is no refracted beam. This is because you've now hit a area called total internal reflection, and this is the principle by which the fiber optics work. If I change the angle, I can bring the refracted ray back. Right? The angle where it disappears is called the critical angle.